Okay, so now that we've got our shoulder controls in place, let's turn our attention to setting up the 3 spine controls that sit between the hip controls and the shoulder controls, and making those so that they will stretch out when our spine stretches out, but also give control over more of the fine curvature of the spine. So let's jump over to the whiteboard, and in this video we'll talk about how we're going to approach that setup. In the next video we'll actually implement the system. So let's jump over to the whiteboard, and I'm going to bring up a new layer. Fantastic. So what we're going to have, we know that we've got our spine, and we know on our spine we have 3 CVs with controls that we're going to be controlling with eventually what's going to become control objects that sit out behind our spine. So we've got those 3 controls that are sitting on the CVs for our spine. If we move those, it's going to manipulate the shape of the spine. Now, those controls are going to exist inside our geometry. They exist inside the geometry for our goblin, and that doesn't make much sense for making the life of an animator easy. Really, it would make more sense if they are offset behind the character. Now, the problem with simply just offsetting these is that if we were to move them, that's going to have the result of moving our spine curve. It's going to have the result of moving the CVs that control is affecting. So what we can do, instead of moving them, what if we were to create a parent for them in the way of these 3 new control objects? We got these 3 new control objects, and they are parents of their respective controls for the CVs. If we move those controls, the CV control will move along with it, but we can have the parent exist in a different space, meaning that we can have them offset behind our character. So we're going to set up 3 controls that are parents of our CV controls, and that's going to allow us to basically work from outside our character, work behind our character, but reposition our CV controls. The animator will never see those CV controls. They'll be hidden. They'll only ever work with those 3 controls. So that deals with having the controls that sit behind our character, but what about the fact that we said those controls are going to linearly interpolate? We said that between our hips and our shoulders, those controls were going to interpolate. So if we moved our shoulders up, then those controls will stretch out. If we were to move our shoulders way down, those controls would be squished right up in a small space. Later on, we're going to deal with interpolating rotations. If we were to rotate in Y, so around what is currently the up and down on our whiteboard axis, the Y axis, if we were to rotate around that, we'd end up applying a twist eventually to our bones, and we'd eventually, in another later video, will set this up so that the controls also linearly interpolate, rotating around by certain amounts of that rotation. We also are going to implement a system whereby if we rotate the controls in X, we're currently looking down X, we're in a side view, so if we were to rotate the control maybe up like so, these controls would rotate up very slightly as well. Or if we rotated our detached, if we had our detached shoulders and rotated our hips down, then they'd rotate back down. So we're going to implement both rotate Y and rotate X in terms of interpolation. For now, we're only going to worry ourselves with the position in terms of interpolation, and not worry ourselves with what happens when we have rotation. So how are we going to deal with that interpolation? Well, much in the way that we created these controls as parents of their respective CVs, so that we could have a position that was modifying another position without necessarily existing in the same location. What if we take the position of our hips, the position of our shoulders, and create 3 nulls that between those linearly interpolate? So we can create 3 nulls that space themselves out evenly between those 2 endpoints. If we move those endpoints, they'll move themselves, spacing themselves out. And if we were to eventually rotate either of those endpoints, we'll calculate a rotation that needs to be applied to those nulls. So we could create those nulls, we could have them space out between our hips and our shoulders. If they were then parents of our 3 actual animator controlled control objects, that would mean as these space out, our animator controlled control objects space out, and thus the CV controls will move. But we can still come in and work from that and move these controls after that and that will still affect those CVs. Now the great thing about this system is that we can come in and we can set a very interesting orientation, or more than orientation, more a curvature on our spine. So we could come in and we could set one control like this, another control in a very sharp angle, then our other control like such, giving us somewhere where our spine's coming in a very steep angle. And then if we were to move our shoulders upwards, we'd end up with something like that, where we'd have our shoulders up there, and our controls, because they'd linearly interpolate, they'd still maintain that offset from that interpolation position. So even though they linearly interpolate, they still have that triangular shape between them. They'd still maintain that relationship. They've just stretched out in the direction that we've moved them. So that means that it's not going to lose that setup that the animator has placed when we linearly interpolate. It's simply going to be an additional layer on top of that fine animator control. So with that, that is an overview of how this is going to all be working. And in the next video, we'll actually get this first part of the linear interpolation implemented by getting their positions linearly interpolated. So with that, that will conclude this video. Thanks a lot, everyone.